So I believe this is being recorded as I speak. Welcome everyone for the webinar on Kubernetes monitoring. You can read the topic for yourself, the challenges and potential solutions using Open Telemetry and Elastic Stack. This is a webinar as part of the Cloud Native Kerala chapter. And we have a great speaker who is joining from across the ocean from Canberra, Australia, New Zealand, none other than MiKe Calizo. So thank you so much, Mike. A quick introduction about Mike. Mike has been in the industry for more than 20 years. I just looked up his LinkedIn just to be sure. So he is there for more than 2 decades, being a professional across different continents, so to speak. A Filipino by birth, but he's a global person. Currently working for Elastic as a principal architect based out of Canberra, Australia. Been in many open source and community events. He runs a lot of community events by himself, meetups and everything. So look up him in LinkedIn and other social media platforms. So thank you so much, Mike. Take it away.
Thanks, Bridget, and thanks for that very nice and kind introduction. Yeah, I was just thinking about that. I've been working in IT for 20 years. That's a long time, eh? But anyway, so more about myself. Um, as Bridget mentioned, Filipino by birth, New Zealand is a New Zealand citizen, but is currently working here in Canberra as a principal customer architect for Elastic. And my main focus right now is Australia's federal government and enterprise customers. Prior to that, I worked as a customer success manager for Elastic, solutions architect for Red Hat, and a lot of other companies like Datacom and TRT and Shell and T Systems along the way. So for today, I prepared a topic with regards to challenges in observing and monitoring and even alerting um, microservices and even the challenge of a non-cloud solution in the industry right now. And I would like to talk about the pain points and how can this be solved by OTel as a standard for for observability. What is OTel and how is OTel send signals for us to gain insights on the application that we are running? um, and of course my own opinion on observability implementation right now and how we can, I would say, improve. And it's open for conversation. We'll talk about that on Q&A. And one of the topic that Srijet and I talk about is the use of AI assistant in observability. And I work in Elastic, so I've seen how this develop and how you can actually take advantage of ML and AI in implementing your observability solution to handle microservices challenges and Kubernetes, in a Kubernetes or a cloud environment. And we'll do a demo. I set up 3 demos to showcase the how you can actually use OTel to uh, gain insights not only from the infrastructure side but also the application and the services that is running inside your Kubernetes cluster. I will also do a demo, on using correlation, because I think when we talk about observability, we need to make sure that we can correlate what's going on, end to end. Not only talking about the traces on your application, but also you need to understand what's happening in your storage, your operating system, as well as in the networking components. And the last part of the demo is of course using AI, how you can use AI, or I would say RAG, for this implementation of observability assistant, and then we'll take a Q&A. So I think we can all finish this within an hour. Now, let's talk about the pain points, right? Of and the architecture that we are trying to uh, uh, we have right now in front of us, right? So the common observability pain points, I would say, is because we have a limited or minimal APM coverage. I would say it has an incomplete information or insight on application performance and monitoring that hides issues. The other uh, problem that we had is we have a minimal metadata, and the lack of metadata makes it hard to correlate signals. Imagine if you have, like, for example, in Kubernetes perspective, because of thanks to microservices, and microservices has a lot of benefit, we're talking of possibly thousands or even uh, multiple thousands of application or containers running in a big application deployment in an enterprise. And of course, the other problem is, we have multiple backends. Using many observability platforms can be a challenge to make signal correlate, and this makes signal correlation almost impossible, right? And on top of that, too many agents on hosts can also waste resources. And we've seen this in what do you call this, in enterprise settings, where actually sometimes agent can consume at least 20 to 30% of your CPU utilization if not properly implemented. Now, let's talk more about Kubernetes observability requirements. Because of Kubernetes power, it becomes, the environment becomes dynamic. Pods and container can scale up and down rapidly, making um, tracking and monitoring very, very challenging. And in some of you who has experience in implementing big Kubernetes cluster, you would have experience and manually tracking what's going on in the application is actually very difficult. And of course, because you're running microservices, it also gives you complex networking. Kubernetes networking can be intricate, complicating network monitoring and troubleshooting at once. And of course, you get the resource constraints. Monitoring resource usage within pods and container requires careful attention all the time. And imagine if you have a lot of pods and containers running, right? And of course, logging and tracing, aggregating logs and tracing requests across distributed environment is very complex. And on top of that, your security consideration. You need to ensure that observability without compromising security is also a challenge in Kubernetes cluster. So here comes the potential solution for us, which is Open Telemetry. And what is Open Telemetry? I put it here in the slide that Open Telemetry is a open source project that provides a set of APIs, libraries, and agents, and as well as instrumentation solution that enable observability in software application. It helps, for me, the power of this is it helps developers to collect, process, and export telemetry data, such as, application traces, application metrics, server metrics, as well as application log and server log. From and it can tackle from both application and infrastructure alike. This data can be used to monitor and troubleshoot application, of course, as well as the most important thing to supplement and gain us business insight into the performance and behavior of your application. or services. Um, and this can decouple dev from ops. Open telemetry allows you to basically separate, the instrumentation of your code from operation that collects and processes telemetry data. This idea, I would say, enables you to focus in instrumenting your code to capture the necessary telemetry data, while the other part of OpenTelemetry framework takes care of the collection and processing and then exporting that data. And for Elastic, we can ingest that so that we can use that data for correlation. That will help you troubleshoot or gain insights on what's going on in your services. This separation of concern makes easier to add instrumentation to your code and change how telemetry data are collected and then processed without you actually modifying the code. And I'll there are ways of how to instrument open telemetry into your application, and I'll discuss that later. One interesting insight as well is that 90% of developers are still relying on log analysis for observability. Log analysis is indeed a common method for observability, but if you are troubleshooting a microservices and the landscape keep on changing. You have different flavor of Kubernetes, you get different flavor of cloud. Adoption of distributed tracing and metrics driven approach is necessary. While for me, logs is still valuable, provide you valuable insights, they can be very, very difficult because it will be difficult to actually sift through thousands of lines or even millions of lines of codes, especially in a complex distributed system. Tracing and metrics offer more structured and real-time visibility into the behavior of application and systems. And that is why, I would say open telemetry is a solution that we should be looking to address, that challenge and observability. Open telemetry supports all these approaches, allowing, developers to choose the right mix for their needs. Um, in that, I would like to pause before, if there is question. Is it right to ask? You guys can ask question here. Is the attendees can ask question here, Srijit?
Yeah,
Or
I
can
mean, if they want, if you have any questions, feel free to
Mhm.
ask it right now
Yeah,
to
okay,
Mike rather than waiting at the end. Okay.
yeah, cool. So I'll continue for now. So the big question is why now? Why do you think we should actually consider open telemetry, especially in a Kubernetes implementation or you know cloud public cloud implementation? So the first thing that I think we should look at why open telemetry is important at this time is because of the multi-signal observability. Open telemetry provides a standardized way to collect telemetry data, including metrics, traces, and logs, and it gives you a comprehensive observability view. Open telemetry also will help you avoid vendor lock-in. By using open telemetry, enterprise can avoid being locked into specific observability vendor solution, uh, enabling you to switch or use multiple vendors as needed. And I'm proud to say that Elastic actually contributed to the open telemetry of CNCF right now and provided a lot of, um, I would say, opinions on how to do uh, and democratize open telemetry and log collections. Of course, scalability with clouds and Kubernetes. Open telemetry is designed to scale with modern cloud native environments, making it, I would say, wheels suited for monitoring application running, especially on Kubernetes and other and cloud platforms. And of course, the aim of OpenTelemetry is standardization. OpenTelemetry is a vendor-neutral open source project backed by a lot of companies like mentioned OpenShift, like Red Hat, and Elastic and other AWS and Google Cloud are also contributing to that, as well as Microsoft. So you know that is ensuring that its adoption and support across wide range of tools and platform is standardized. Um, when it comes to ideal, and this is where I say potential solution of observability using uh, OTel or Open Telemetry, is that we need to minimize agents and use a single agent, or at least use lightweight and efficient agents that minimize resources usage and overhead in the host. And I would say when it comes to that, OTel is the best uh, approach when it comes to minimizing agents, and it integrates seamlessly with the likes of Elastic. Another one is, of course, resilience, or I would say optional resilience. It will provide you mechanism for resilience, such as failover and redundancy, but make them you can make them optional to avoid unnecessary complexity. So some of the approach that I see a lot in, at least in our customer land, is the use of Kafka. And to do that, Elastic and OTel has no problem on sending messages to Kafka to assure the delivery of the data. And another one is flexible signal routing. It allows you flexible routing of signals, enabling customization based on specific needs. And and of course, this is very, very important because you want to make sure that you can send your data into multiple locations if, if possible. And of course, the biggest one is signal correlation, an implementation or a mechanism for correlating signals across different sources, such as you can get logs from Google Cloud, for example, and AWS or Azure, or even on a multiple Kubernetes cluster, and will still provide you a unified view of system performance and health. So that, for me, that is the high level observability, ideal high level observability architecture. And I think we're very near on getting into that, because more and more are actually adapting or using or introducing OTel uh, as a as a standardized way of collecting logs, traces, and matrix. Now, this is how open telemetry signals are architectured, or on a high level. OTLP, or Open Telemetry Protocol, provides several key signals for observability, as you notice here. Um, Tracing, for tracing purposes, OpenTelemetry enables tracing of requests across distributed system, providing insights into the flow of requests and by identifying bottlenecks and issue. Metrics, when with OpenTelemetry, you can collect metrics about your application and infrastructure, so that you can understand the performance and resource usage. And then, of course, OpenTelemetry collects logs as well. So supports logging by providing hooks into standard logs framework, allowing you to capture log messages and correlate it with telemetry data. And that's where you can attain the end-to-end correlation. And and it it is all possible because of OTLP, or Open Telemetry Protocol. This protocol allows communication between Open Telemetry components, and native OpenTelemetry compatible backends. And that's the key. You cannot force everybody to use OTLP. But what's the most powerful way of implementing OpenTelemetry is it handles OpenTelemetry compatible backends, ensuring wider operability and ease of integration. Now, signal and routing, right? So the purpose of open telemetry is to collect, of course, process and export those signals that are collected on the backend. Signals are system output that describe underlying activity of operating system and, of course, application running on the platform. A signal can be something you want to measure at a specific point of time, or you can go back through, specific timeline and actually get information that you need. You can group these different signals together to observe the inner working and say of the same piece of technology under different, view or angles. And for me, OpenTelemetry currently, it's not for me. Currently, OpenTelemetry supports uh, traces, metrics, and logs, and even events that are specific, that have specific type of logs, and even user profiles on profiling, host profiling or user profiling is being worked on right now as well, which is what I would say will complete the view of observability, because I want to understand real user experience, for example. So I want to make sure that every time someone log in to to my website, I understand whether they get what they want, or are they waiting for a long time to get the information that they need. So that's something that I would say will make this open telemetry implementation very powerful. So the question right now is, should we use open telemetry everywhere? Well, this idea of using OpenTelemetry across all layers of your application stack and infrastructure can be possible. And you can start by, currently app tracing, app metrics, and logs are being collected through instrumentation of OpenTelemetry. And with the help of with the use of the native bits, or other compatible collection of infrastructure from Elastic, you can get service metric, orchestration metrics, and also host metrics. Right now, I would say it is possible because of the community driven, I would say, development. So this is how OpenTelemetry APM injection happened. OpenTelemetry APM agent injection can be done via auto automation during the compile time. So add auto libraries to the build for these languages here, and runtime, which is basically binding auto libraries at runtime. Uh, and I will be showing that this how you can actually do this depending on our time. And of course, um, automated runtime and this is what I implemented in my cluster right now. Automatically bind all the libraries to run in a Kubernetes environment. And this is open telemetry instrumentation and elastic plus Elastic Agent. And I will be talking about Elastic Agent because I work for Elastic. Now, imagine this. If you can integrate Open Telemetry and Elastic Agent, and I'll give you a blog what Elastic Agent is. It's basically an agent that runs in your host, and it uses bits technology to collect logs, metrics, and events. With this combination here, this can offer you a powerful way to collect telemetry data across different environment. Elastic Agent's cross-platform compatibility makes it suitable to deploy in a diverse operating system and Kubernetes environment, collecting all those host, infrastructure, networking related data. And this can, fleet manager can leverage so that you can automatically push policies allowing you for a centralized and remote configuration of integration, enhancing scalability and manageability. So, this is something that we keep on pushing to our customer, because when you combine OpenTelemetry instrumentation and Elastic Agent, it will actually be possible to manage everything from a single location and change policies as needed as well. So before I continue to the next slide, which is basically, talk about the signals, is there any question?
Y-
Silence means no, I guess.
Yeah, I don't see anything in the chat. Maybe they are parking it for the end, Mike. Yeah.
Okay, cool. Okay, I'll go ahead. So I'm talking about signals, right? And we talk about tracing, but let me go back to the time where, on the old days, where the entire strategy around tracing application was to instrument, our code with, system error calls, and then tail the log file on the production server. While this is not ideal, it is the best we had at the time, and it did serve purpose, although it cost a lot of productivity. And I'm a proud, I code a bit to make sure that I capture all the logs, and send it to syslog ng. And for the purpose of troubleshooting, I can go there and look for issue of MySQL, for example. Today, that approach is entirely a different beast. Modern applications today are usually comprised of microservices. Although this gives organization extreme flexibility, right, and reusability on by basically modular their capabilities and being able to scale, these services also gives us challenges. They make life of DevOps organization basically extremely difficult if they don't have the proper tool to monitor this type of application. Imagine if you have, say, in my demo, I have 800, around 800 pods or container running. So imagine if a person who is, and that is only running this simple uh, e-commerce application from Google, right? Imagine if a person working on a, on as a DevOps, looking at issues without a proper tool, that will absolutely use their whole day to find the issue. All right, so that's something that I think we should look at, why we should implement modern observability solution, and OTel, I would say, is in the forefront. Now, the barriers for adoption, I would say, is always, of course, vendor lock-in. This is a big problem for, of course, for customers, or for enterprise, because proprietary capabilities around data collection and storage, customer can basically lock in for a lifetime. Of course, cost as well. There are a lot of vendors or solution have their per app, per host licensing, which is, which can result to escalation of cost as customer, or as enterprise grow their app footprint. I hear from one of our customer that they have millions, not thousands, but millions of containers running around to for their banking system. And because it's high cost as well, it is also hard to create business case around, of course, APM, which is basically the way you trace your application performance. And of course, in Elastic, tracing, I would say, is is a solution that needs some key capabilities, that is, that you so that you can support your implementation, right? Firstly, it needs to provide excellent capabilities around ingesting data. So with Elastic Stack, you get open ingestion platform. You can mix and match Elastic APM agent or OTel APM agent to send data to Elastic without basically compromising on the fidelity of the data. Second here is, of course, good APM solution needs to provide top-notch user experience, right? With Elastic, you get exceptional capabilities around being, to analyze different signal, to do root cause analysis, and exactly what I'm going to show later on. And when it comes to, user experience, what we want to show, or what we want to talk about all the time, is you should be reducing your MTTR, right? And lastly, for me, a good APM platform needs to be cost effective. Now that we all, know the time series signal data for APM can be very difficult to understand, this makes the cost prohibitive. The most platform to ingest all of the data. I have a customer who is ingesting data for about, 15 billion documents a day. And because they are using Elastic, previously using a competitor, because now they're using Elastic, they can save a lot because of the different storage tiering on Elastic. They can now retain longer data on using that, from the APM, so APM traces that they have, and retain it for, for longer, even up to uh, 5 months, by storing it at the frozen tier. And when I say frozen tier, they put it as a flat file on an S3 compatible storage, and then rehydrate it if needed, if they need to investigate for something. So by that, I would say that's the important advantage of making sure that you can move around your data in different storage tiers, so that you can save a lot of money. So logs has been around forever. What new value can Open Telemetry bring? So that's really a good, good question. And for me, logs has a lot of legacy attached to them, right? Since there were, I would say, the OG of observability mechanism, this resulted into logs traditionally being disjointed from traces and metrics, both in terms of collection and analysis. So Open Telemetry seeks to solve this problem with how it handles logs. Firstly, it creates a single unified data path for routing traces, metrics, and logs from the apps to the backend. And then of course, secondly, it allows for you to easily do a metadata inclusion in the log signal, so that now you can start correlating them with traces and metrics in your analysis, hence attaining the end-to-end observability view of your application. Now, with OTel, of course, this is the when I say the models for collecting logs. With OTel, you can use existing logging framework in your apps. The OTel hook takes care of the injecting metadata into log signal. So OTel supports three different log shipping pattern. Right. Firstly, of course, using the direct OTLP, which is basically shipping logs directly to the backend using the OTel protocol. And second is to write the logs into log file and use the collector to ship the logs in the backend. And I've seen a transition, I would say, architecture to hotel doing this, because they cannot just remove their old way of collecting logs, because their developer uses old methodology on collecting logs, and for them to replace it with hotel, they need to you know refactor their application, and that's not an option for them. And third is to write logs to the file and use elastic agent to ship logs to elastic backend. And this is where bits is useful, or even shipping it through logstash for filtering before sending it to elasticsearch, and use elasticsearch as a backend correlation, because OTel can now use the metadata in the ingested data in Elasticsearch. Sorry, I was not able to click that. Now um, with logs with Elastic, so on the ingest side of Elastic, we use a schema on write to index the logs. This optimizes the data for a really fast searching. And and if you are talking about time to market and making sure that you capture issues in your application, you need to have a fast search solution. In addition, we transform the data into Elastic Common Schema, which is currently donated to CNCF as well. And ECS uh, provide you a lot of out of the box analytics for for enterprise that are using them. And of course, the user experience curated for you on Elastic platform is, I would say, really good and top notch. You can, because once data is ingested, you can apply ML or machine learning to the log data in order to filter out the noise from the signal. And honestly, there will be a lot of data that you need to collect from thousands of your containers, and not all of that is useful for you. And I think I can show that later on in my demo. This is very, very helpful, since you are now letting the machines to work instead of having to use human or SR or your SREs or your DevOps to sip into thousands or millions of logs. So similarly, there are some key features of Elastic that makes it extremely effective uh, as a platform. So that you can store data and analyze that metrics later on. Before I go to this next section, is there any question? Okay, I'll continue. Yeah. Because I would like to. We still have time for our
Michael,
demo.
can you talk more about on beats, please?
Yeah, we will. I don't know if I have time to cover that right now, but yeah, we'll. I use bits to collect metrics on the server, so maybe in the demo I can show that to you.
Okay, okay.
So this is my observation about observability. As an open telemetry becomes widespread, I hope data collection is going to be streamlined, right? With more services directly supporting OTel or contributing to the integration of OTel collector, this can lead to a shift away from proprietary APM agents toward building an OTel standardized framework. And I think we're very near on getting there because um, I won't mention other companies, but we see some uptake on contributing into open telemetry from other vendor as well. But Elastic itself is very, very active in this because we have different strategy, and we embrace OTel because I think because we can leverage from what OTel can provide in Elastic, right? As a solution. So for me, the value of Open Telemetry lies in its ability to provide a unified experience for analyzing multiple signals. And really, I would say the magic is leveraging machine learning for root cause analysis. Because without machine learning, although you can collect data comprehensively, you will be using a lot of your SRA time or DevOps time to actually go through each alerts that you receive and really use and train these people to get into root cause. But with machine learning, this way of doing it can minimize the time because you are leveraging the machine learning capability, offering simple tools for end user to analyze data and basically supporting flexible deployment across different environment and implementing, I would say, intelligent cost control, enabling workflow management like SLO and case management, and providing crowdsource assistance through AI, through platforms like Stack Overflow and AI-based chat. And in my demo later on, you will notice that some of the answers from when we ask question from observability assistant comes from Stack Overflow as well. So that's that's where I stand to where and how OTel can actually transform the current observability solution. Now, I'll talk a little about this AI assistant because Srijit just mentioned to me last night. Can you actually demo a bit about AI? And I was mentioning to Srijit, I'm actually thinking of doing that, but I get become busy. But yesterday, 2 days ago, I actually managed to get it running on my cluster. So Elastic as a platform provide a suite of tools that enable our customer and community, open source community, to build anything from custom website search and then to a full-blown custom application that are powered by, of course, Elasticsearch to enable you to have end-to-end observability out, which is out of the box solution from Elastic. And if you're thinking of security as well, you can do that in a matter of seconds. And we can ingest data, semi-structured data, to even unstructured data with the aim to reduce risk, reduce cost, and more agility towards your solution. So for every observability engineer, the Elastic AI assistant can help you, you know, detect, analyze, and remediate. You can chat with AI assistant to interact with contextual prompt. This is like the open AI that we have in ChatGPT, which is basically located throughout, your observability dashboard. So you got a single pane of glass to investigate and ask question if needed, and see and basically allow you to understand user profiling, application performance monitoring, or APM, by explaining APM errors and provide remediation and suggestions. It can also help you in your infrastructure observability by explaining the process that is running in the host and why is it running in there and not on the other host. And when it comes to logs, it can explain logs messages and generate search pattern to actually find similar issue, which is very important, especially on a distributed uh, architecture. And also explain alert why you receive an alert, what is the possible cause, and possible remediation suggestion for log rate changes, right? And imagine, and it happens all the time, right? If you're an SRE, you might wake up at 3 a.m. and you see a spike on logs, and also spike on what you call this, utilization, and you're looking at thousands of lines, and getting that information might be difficult unless you're very very good in what you're doing. And and most, nothing wrong about the ops team about that, but not everybody has the same skills. Right? You got entry level, you got very good senior level, and not not everybody is doing the same approach. So AI can leverage and help that to remove the gaps, for example, in your implementation. And of course, Elastic as AI assistant for observability provides you contextual prompts, empower your engineers, combine with internal knowledge base and external sources that you can define. It's open and transparent, and it supports multi models in LLMs. So for for how it is done, an engineer or an SRE has now an ability to ask question in a natural language and get a valid and meaningful response, just like this. And we're going to demo this in the next section. And the AI assistant that we have in observability uses Elastic Semantic Search Engine to basically recall data from both internal knowledge base index to create retrieval augmented generation, which is RAG, and then adding data such as runbooks, GitHub issues, and internal documentation, and even Slack messages to knowledge base to give AI assistant a full context to provide specific assistance to your engineer or SRE. You can add information to the knowledge base by asking the AI assistant to remember something while chatting, for example, remember this for next time, and it will index that information in Elasticsearch, so that when you ask the same question later on, it will be using the same context or knowledge that was found earlier. And of course, AI assistant uses functions to include relevant context in chat conversation through text, data, and visual components. And this is how the architecture of Elastic AI that is used in uh, uh, observability assistant. So the advantage of using this is that it uses iterative human language, knowledge, and content creation. It overcomes limitation of using LLM models alone. So it can basically, you ask the question, AI powered semantic search will go directly and search for information from your local data source, and then search it on the Elasticsearch. It will then send the question to LLMs and or private LLMs, and you get the right answer. So it has access to private data so that you can retain the stewardship of your own data. It allow role-based access to secure public sector standards, and it has a real-time update all the time because it's using the, it connects to the real world information, and control what Gen AI treats as facts to fight hallucination, which is it's real in this kind of implementation. So this is how observability assistant is implemented on Elastic, and you'll see that in the demo later on. So I'll go to the demo, and I have 3 parts demo that I'm going to share. So first, Elastic Observability, um, using database outage from the logs and APM collected data collected by OTel. And then I'll go through finding known unknowns, still using the data collected by OTel. And then I'll look at uh, log spike and revenue impact using observability assistant, which is basically an AI, what we call this, demo. So let me actually start by showing this first. So I have implemented a cluster on my GKA account, and this is the current. I have 10 hosts right now, and this is that's where I run my Kubernetes, and I have 818 Kubernetes right now, and I can drill deeper in there. What's that? I think I need to, because I opened this earlier. I can basically drill deeper in here to find information about uptime, pad logs, and then metrics, as well as APM traces. And of course, inside the pods, as everybody know, there are multiple containers, can be multiple containers. So I have 813 because I have some sidecar running on my implementation. So now this is the services that is running. And if you look at the service map, here are the application. Wait, it's a. Can you guys still see this? So this is an
Yeah, we
application that has a Node.js, an Nginx, a Go, and a Redis, and a Postgre running, right? And if I go to traces, I can simply just go trace the application. And all of this, if you're familiar with Jaeger, similar to what Jaeger can get, I can also get it from through in Elastic through OTel. And what I can also do is I can actually see the last latency distribution if I trigger a traffic, and I can understand dependencies based on comparison as well. So this is, this is a walkthrough of what I have, but I also have synthetics monitoring so that I can make sure that uh, all the, what you call this, website that I need to connect are running actually. So let me go to the proper demo. So what I'm going to do and show is the outage, database outage. And let me actually, you guys can see this, right? You guys can see the data, the the service map.
Yeah, we can.
So in this example, what I'm going to show here is we want to investigate the unhealthy service detected by the anomaly detection jobs that I set up, and actually find the root cause of the problem, and by basically quickly inspecting the logs with interest, inspecting the logs with interesting highlight using anomaly detection. And what we aim here as an operational benefits is by using ML, uh, you know, the by using ML without me having an ML background, for example, or ML training, I can find problem quickly and potentially resolve outages quickly as well, so that we can save the organization a lot of money, right? So what we say, for example, we've just received an alert, and the alert tells me 5 minutes ago I have an active alert, and that alert is related to. I look at the service map. I can find, oh, the product service is basically causing a problem. So what I do, I will start reviewing, of course, this service map, which captures the response time and each service every time the application is utilized, and it takes and I will take a look at one of the affected service. So for here, we know that there is a problem on a product catalog service, and the max score for that is 96. So obviously there is anomaly, but we want to get to see the details. So what's going on in there? Um, so when I review the this basically this, I can see already the anomaly, right? So look at that anomaly in here. So very high anomaly that I see. Now, what we want to do is we're going to look at the expected bound. So because I want to understand what causes the problem. So when I look at the expected bound in here in the throughput, I can see a potential problem, but I want to make sure, and I want to actually look at the failed transaction rate. And inside the failed transaction rate, 100% failure for from this time, my time 750 550, for example. And why is that a problem? Well, I can see from here that there is a postgre products relation not does not exist. So if I imagine this, maybe the database, one of the database that I am trying, the application trying to connect actually was dropped. So what's going on? So let me actually go to categories. And inside categories, what my hope is I can find and filter only postgrade, because I understand that it's actually postgrade that is causing the problem. So imagine if you don't have these tools, you are going to look at thousands of lines here. But what I'm interested only based on the failure rate that we see is I want to zero down on the PostgreSQL logs. And in the PostgreSQL logs, what I want to do is a suspicious process that might cause some problem, right? So in here, what I'm going to look at is um, I should be finding a PG bench problem here. So that is a database was shut down. So what causes that database shutdown? Now I can basically look at the problem and give me some more details. So database shut down multiple times. Why is that? So looking further, I can maybe look at uh, some aborting transaction as well. And what I want to do here is what is causing the terminating connection. So what I want to do is I'm going back to this database shutdown and look at the problem in context. So I can see that data is shut because of the trust authentication that is causing the problem. Now let me close this, because what I want now is I want to make sure that I can explore the logs, and that will tell me already that the problem is because of the database being shut down. So for me, what I am showing here is this is only possible because I have implemented a ML that don't need to sip into a lot of data, because I can filter specific information based on the previous what you call this, based on the failed transaction rate, which tell me that this is the problem causing failure on the application. So ML implementation, I would say, is very easy, and it gives you a lot of leverage to investigate logs or issues within your application. I'm just conscious of time, so I'm going to pivot on the next demo. And my next demo is about finding known unknowns using APM correlation. So in this demo, I'm going to access and show a e-commerce website, right? And what I will simulate is to for a person to buy an old typewriter. And because I clicked that and it took a lot of time. So for me, that is already a problem. And I want to understand why. So what I want to do now is I'm going to investigate on my um, on my the performance of the card service, because that is the application that we just click, the card service, and we know that from our service map. So in here, I can what I give you is a visualization of a 24 hours worth of data that I can see, and the average add item service takes around 2.7 seconds. So I'm going to deep dive and basically find what's going on and why is it causing me a lot of waiting time. So when I look at this website as earlier, as at this page as earlier, we want to scroll down. We want to understand if there is a failure, and there is no failure rate, but it's just low. So it's not failing. There is no component that is causing the problem, but it's slow. So I want to understand what causes the slowness, right? So what I will do is now there are actually two clusters that I think that is causing the problem. The when I look at the latency distribution, I can see, most of the time the service responds quickly, taking only maybe around 90 milliseconds. But the other cluster is taking 9 seconds to respond. So for that, I can see that there is a latency problem. So what I want to do now is actually to find out what causes that problem. So I click on the timeline that we see, the add item application itself, and see what causes the problem. And if you don't have this, again, if you're just using I'm a proud user of command line, but if you're just sifting through these logs, it will be very difficult to find this, right? So we can see when I click this event, I can give the elastic observability already can give you a ton of information. I can see information such as which cloud this is running, what provider, which cloud this is running, what provider I'm using, what the cloud IP, what agent are running, and even the timestamp, right? So that already give me a complete view of what's going on in my application. Now, what I want to do is I want to review and find out by looking at the latency correlation, right? So right now it's generating a correlation, and it's getting all previous ingested logs so that it can give us information why why the problem or the slowness is happening. So it will take a little bit of time because it's getting 24 hours of data. And in here, if I scroll down in here, I can already see what what causes the problem here. So for me, it looks like version 1.7 of uh, that application is the common what you call it, common issue, right? So 1.7, and what I'm going to do now is if I click this information here, it gives me a information about the latency that happens. So average of 42 milliseconds. So I am confident that the version 1.7 version is the root cause of the latency issue on the add time services. So you again, using these tools, I can troubleshoot problem. I can find the root cause going through 24 hours of data simply by looking at the data collected by OTel and Elasticsearch, going through infrastructure application and correlating it so that I can find problems that I need to find so that I can solve that very slow response on adding item on the cart. I don't know if I cannot see if there is question, but what I'm going to do now, Sujit and team, is I'm going to Fibot and the third what you call this demo, which is basically logs a log spike alert, and let's see if and what I'm going to do is to showcase the AI in Elastic. I pre-connected this to Azure AI, just for your information, so that it can basically give us a what you call this a response that is human readable and that we can understand as well. So in this again, go using the same type of what you call this same type of uh, data. Um, there in observability and for implementation, there's a lot of things happening already, right? AI is one, and I think this is, for me, this is very very useful. And I am advocating this every time I had a chance to talk to different people, because it will give you it, AI, if implemented properly, can be a force multiplier. So again, going back to the notion that, imagine if you're an SRE and you get up in the morning around 3 a.m. and you see the spike of logs and the spike of traffic, and you are not sure what happened. And by saying that, this is an example alert, for example. And I can, by looking at that, I cannot even tell what causes the problem, right? But it shows that it reaches the lag threshold, right? So when I want to basically let me actually when I want to see what's going on, I can click and drill down deeper into the cause of the alert. Again, this is me using the ML implementation. Right now, it's taking all the data that was already ingested in the Elastic, right? So i- now that all data are ingested, and what I see here actually is that there is this what you call this application, and I don't know if you're familiar with PG Bench, but PG Bench is basically a tool that database use to test, the application, the database performance. But you will wonder why is it running in the what you call this on the production environment, right? So what can be a problem here, right? So what I want to do is I actually want to that find out what is the potential root cause. So in here, I have an AI assistant running, and automatically, if there is an AI assistant, it can give you information basically that is already available in your case in your knowledge base, local knowledge base, if you're connected your LLMs to that. Or in my case, I connected this to Stack Overflow, so it's getting information about the logs that I'm suspecting. So I click in here, and it gives me possible causes and remediation information. So if you notice, the answer here are publicly available, right? But what I want is actually wanted to understand further. So I can then ask the AI, what you call this, the AI assistant. And just like your, what you call this, your open AI, or you can ask a question, but what it does is it's getting information from the environment, because it has ingested the data from the environment that is currently implemented, right? So now I want to understand, did this incident have impact on my revenue? And let me actually find out if there is. So I asked that question, and actually it will give me an answer, because it looks at the RAM, the APM, and services through ML. So in here, it gives me information through throughput, and it explains that the time series data from checkout service shows average transaction approximately 26.36 requests, which basically, well, it can impact my revenue, right? So what I want to do now is I'm going to use Anima. I'm looking at the old data right now, right? So that's even looking further from the older data that I have ingested in this environment. So that question, the AI assistant is thinking, it can give you information about, what you call this, about visualization of data revenue, and explanation also how he created the data revenue. And furthermore, we can ask further question like, how much revenue did we make, and use ESQL, for example. So in here, it will use ESQL to search information that will be useful. And there, of course, it will run a query using AI assistant, and it will give you an exact calculation of, of how this is done from a query that you can run in your Elasticsearch and give you a total of approximately 8,500 revenue loss. So for me, that is how powerful observability AI, if implemented properly in such environment. So in here, I'll take a pause because that's all my demo, and I think we just have enough time for Q&A.
Yeah, thank you so much, Mike. Yeah, we do have two questions, especially on the OTel.
Mhm.
Came from Monish.
Yeah.
First question is basically on whether OTel can collect application metrics if we install the OTel package to the application, or do we need to make some custom code for that?
Yeah, now there is some good example about that. If you go to Hotel example in the internet, you don't need to do extra configuration. It automatically support. If you remember, let me just go back to this. It automatically support this language.
Okay,
And so you don't need to do extra coding. You can actually leverage the what you call instrumentation of attaching OTel libraries to your application, as long as it's listed in this supported language.
yeah. So I see Java there, so it should work with JMX metrics as well,
Yeah.
right? Okay,
I am not familiar, but I don't know if it supports GMX metrics right now. I don't think so.
okay,
Yeah,
okay.
maybe the best way of doing that is to collect that using Pilebit, and then ingest it in Elasticsearch and use that as to get a wider correlation.
Perfect. Yeah, so those were the two questions, but I think the demos were really great. In fact, it was new to me, though I knew about Elastic from an open source angle. Okay, so
Yeah.
thanks for that. And Mike, I know it is all open source, but just verifying it again, all are open source, right? Whatever you did now.
No, so the AI is not open source. It's
Okay,
behind paywall. Yeah, but because that's yeah, I think it's called enterprise capability of Elastic. But the rest that I show you is all available on open source.
perfect, perfect.
Yeah, OTel
So the
and
AI model may be something which you trained in house,
yeah, it
right?
uses S-Ray and ELSER, which is basically a relevance engine in Elastic, and it
Okay,
connects. That is to collect, because you need to instrument also indexing those information. What information you're going to get, so that it will be used when you ask the question, and then send it to LLM, so that it will return an human readable answer.
understood.
So yeah.
Perfect. Any further questions? I know it's been very interactive demo in the sense that see, live demos are very difficult, but thanks Mike for doing it. Okay.
Yeah,
Any
no worries, man.
yeah, any final questions before we let Mike go and wind up our presentation? Okay, so I'm just going to stop the recording just to save
Mhm.
our storage.